All right, let's jump right in. Today, we're diving into what is basically a real-life environmental detective story. The crime scene? Florida's coastline. The victims? Its precious coral reefs. And the clues? Well, they lead to a place you might not expect. So here's the deal, and it's not great. Florida's amazing underwater cities, its coral reefs, they've been in trouble for decades. Now, we all know about the global threat, right? Climate change. But that's not the whole picture. Something else is kicking them while they're down, making it harder and harder for them to recover.
And that's where this story gets really interesting. It leads us to the central mystery we're unpacking today. What if the real key, the main threat, isn't just out there in the ocean? What if it actually starts right here on land, on our streets, our lawns, every single time it rains? Okay, so to get to the bottom of this, we're going to follow the evidence, just like detectives. We'll start with the state of the reefs, then we'll dig into this land-sea mystery that had scientists stumped. After that, we'll see exactly how they use data to crack the case, uncover the who and how of the pollution, and finally, and this is the best part, we'll look at a solution that's actually manageable. All right, first up, let's get a closer look at the crime scene itself. Florida's reefs. While climate change is kind of the global villain in this story, it turns out there's a local accomplice that's making everything so much worse. And that accomplice? It's poor water quality. Yeah, think about it like this. You've got a reef that's already stressed out, right? Weakened by warming waters. Then, bam, a flood of extra nutrients, stuff like nitrogen and phosphorus from fertilizers and wastewater on land, pours into the ocean. This stuff is basically junk food for algae, which then just explodes, growing all over and literally smothering the coral. It's a disaster. It messes with their ability to reproduce and even makes them way more likely to get sick.
So that brings us right to the heart of the investigation, the land-sea mystery. Scientists had a pretty good hunch that pollution was the accomplice here, but a hunch isn't enough. They needed to follow the trail. They needed hard proof.
And for years, that was the big problem. Everyone kind of knew there was a link between what happens on land and the health of the reefs, but proving it with actual data? Almost impossible. The evidence literally just washed away with the tide.
And this quote from the study just nails the why. The worst of the pollution, the biggest clues, they all show up right after a huge storm. So how in the world did they solve this? Well, this is where the investigation takes a turn. The scientists basically became pollution detectives, but they weren't working alone. They had a new partner, a really powerful one, to help them crack this case wide open. And here it is, their secret weapon, something called boosted regression trees. Don't worry about the name. Just think of it like a super smart AI detective. Its whole job is to sift through this absolute mountain of messy, complicated data, way too much for any person to handle, and find the hidden patterns, the secret connections that tell you what's really going on. So here's what they did. Over 3 years, they were out there taking more than 1,000 water samples from 29 different reef sites. At the very same time, they were tracking every drop of rain and measuring the water flowing out of 4 huge coastal canals. Then, they took all of that data, every sample, every measurement, dumped it all into their AI partner, and basically asked it one simple question: what's connected to what? And you know what? The AI delivered. Big time. This is the moment, the big reveal, where we find the pollution connection that was hiding in all that data. The model pointed its finger at 2 main culprits, 2 different pathways for pollution to get from our streets to the reefs. First, there's the rain itself. It just washes all the gunk from the city landscape straight into the canals. But then you've got the second part, the canal outflow. This is the big engineered release of all that collected fresh water and all the pollution in it straight out into the ocean. And the connections it found were super specific. It wasn't just a vague, rain is bad. No. The model found that heavy rain directly caused a spike in phosphorus on the reefs. In fact, get this, the single best predictor of a phosphorus pollution event was just looking at the rainfall from the past 24 hours. That's it. At the same time, when there was a high outflow from those canals, when they opened the floodgates, that caused a spike in something else entirely, nitrogen compounds. This showed a direct, almost mechanical link. Water managers open the gates, and boom, a little while later, nitrogen pollution pops up on the reefs. Cause and effect, clear as day. Okay, so just how sure were they about all this? How strong was this connection? Well, the AI gave them a number, 79.7%.
So what does that number even mean? It means that the model, just by looking at rainfall, could explain almost 80% of the variation in phosphorus levels out on the reefs. Think about that. This was a solid data-driven connection.
Okay, so what do we do with all this? That's the big question, right? And it brings us to our final section, a manageable solution. Because, finding the bad guy is one thing, but the really exciting part of this story is how this new knowledge completely flips the script and turns this problem into a clear path forward.
And here's the beautiful irony in all of this. The very systems that are delivering the pollution, those canals, they're human-made. They're flood control systems. And because we control them, it means we can start managing them a whole lot smarter to protect the reefs. This is where the study gives us this amazing concept called a safe operating space. You can just think of it as the sweet spot. It's the set of conditions for both rainfall and water flow where the pollution on the reefs stays low. And this isn't some vague, let's do better idea. It's a sharp, clear, data-driven target that water managers can actually aim for.
And look at how specific this gets. The data basically gives them a playbook. Want to keep nitrate levels down? Okay, try to keep the water flow over a 3-day period below 75 cubic meters per second. Worried about phosphorus? The danger zone really kicks in after about 10 millimeters of rain in one day. See? These aren't vague, abstract problems anymore. They're concrete, manageable numbers. Which leaves us with one last massive question. We started this whole thing with a dying reef and a huge mystery. The data led us on this incredible journey, from the streets to the sea. It pointed out the culprits, and then it handed us an instruction manual. So if we can now predict pollution with this kind of crazy accuracy, the real question isn't what's the problem anymore. The real question is, will we actually use this knowledge to manage our water and, just maybe, save our reefs?